Welcome to The Explainer. Today we're going to tackle a really complex medical mystery, one that happens inside our own bodies. We're on the trail of a molecular fingerprint that is completely revolutionizing how we understand and even treat the disease known as a lupus. Okay, first up, the lupus puzzle. And look, to really get why this is such a breakthrough, you first have to appreciate the sheer scale of the puzzle that researchers were up against for decades. So this is the central question, right? Lupus, or SLE, is an autoimmune disease where the body basically attacks itself. But the thing that makes it so maddening for doctors and patients is how wildly it can change, not just from person to person, but in the same person from one month to the next. Now, we've known for a while that genetics are a huge piece of this puzzle, but here's where it got frustrating. When scientists did these massive studies scanning thousands of genomes for clues, they just hit a brick wall. All the known genetic risk factors they could pinpoint only explained about 30% of why the disease runs in families. And this giant mystery, it has a name: the heritability gap. I mean, think about that for a second. A 70% gap in our understanding. It meant that for most patients, the genetic story just didn't add up, leaving everyone trying to manage this incredibly unpredictable illness pretty much in the dark. So, with the pure genetics angle leading to a dead end, investigators had to change tactics. They started looking at a different prime suspect, a really crucial part of our body's emergency response system. And they zeroed in on something called the interferon pathway. Now, the best way to think about this is like it's your body's viral burglar alarm. When a virus gets in, interferons are the proteins that sound that alarm, telling your entire immune system, hey, get ready for a fight. And this right here, this shows the process perfectly. An interferon protein latches onto a cell, and that kicks off this whole chain reaction inside. This cascade ultimately wakes up these special proteins that march into the cell's nucleus and start switching on a whole set of defense genes. Okay, but here's the kicker, and what this slide shows so well. The difference in lupus. In a healthy person, right, the alarm goes off when there's a virus, and, this is key, it turns off when the virus is gone. But in a lot of lupus patients, that alarm gets stuck in the on position. It's just blaring 24/7, forcing the immune system into this permanent state of high alert that leads to all the chronic inflammation and damage.
So if this alarm is always on, you'd think it has to be leaving some kind of evidence behind at the scene, right? A molecular trail for detectives to follow.
And yep, that's exactly what they found. This constant state of alert creates a really clear molecular fingerprint. It's a distinct, consistent pattern of genes that are just switched on, way more than they should be. And they gave it a name: the interferon signature. And this is the smoking gun. This is a heat map from one of the big foundational studies. On the left, you've got samples from lupus patients. On the right, healthy controls. Each little row is a different gene. Just look at those bright red areas. That's high gene activity. It's that blazing hot genetic fingerprint, clear as day. I mean, the difference is just undeniable. So this signature, it's made up of a whole crew of specific genes. We call them ISGs, or interferon-stimulated genes. And just like a real fingerprint has its own unique patterns, this genetic signature has its key markers. These 5 you see here? They're kind of like the most wanted list, the culprits that are always showing up as being way overactive. But here's the thing. Finding this fingerprint wasn't just some cool, neat academic discovery. No way. It totally changed the game, because they could turn it into an incredibly powerful tool to use in the clinic. I mean, check out this quote from a major study. It's just wild. Researchers followed patients over a long time, and they found that this signature, it didn't really change much. While the patient's symptoms might flare up and then calm down, this molecular signature stayed remarkably consistent. In fact, it was more stable inside a person than their blood pressure readings. Just let that sink in. Okay, so why is that a big deal? Well, because that stability makes it a fantastic predictor. By just measuring a patient's interferon score at the beginning, doctors realized they could actually predict how severe their disease would be, how many flares they'd have, and even what dose of medication they might need over the next 5 years. And get this, we can literally watch treatments working at the molecular level. This shows the signature before and after a high-dose steroid treatment. See all that bright red and yellow before? That's the signature, roaring. And then, look at what happens after. It's almost completely wiped out, all cool blues and greens, just a few days later. It's like a visual confirmation that the medicine is hitting its mark. So, where does this leave us? This discovery has completely transformed how we think about lupus. It took this mysterious genetic clue and turned it into a real, practical predictive tool. And maybe most importantly, it's opened the door for a whole new generation of targeted therapies. Therapies designed not just to treat the symptoms, but to finally get to the source of the problem and shut down that faulty alarm for good.